when you're writing your dissociation equations, you write it for one proton at a time. So because sulfuric acid can release a second proton, you write a second equation. So HSO4 minus plus H2O. This time you use a double arrow when it releases the second one. After it's released the first one and it's strong, it's a little bit more stable now. It doesn't really care about releasing the second proton. So that's why even though sulfuric acid is strong to begin with, the second time it's actually a little bit weaker. So then this turns into SO4 2 minus plus H3O plus. So then tell me, Arez, looking at this equation, sulfuric acid, how many protons does it actually release?
2 in total.
2 in total. Keep on going for me, Arez. The question's given us the concentration of sulfuric acid is 1 times 10 to the minus 5 molar. That's the concentration of the acid itself. If I want the concentration of the protons, what do I have to do?
Use the molar ratio that
Yeah,
you get from the equation.
Yeah. What did you tell me the ratio was? Each acid releases how many protons?
Each acid releases 2 protons.
2, good. Each acid releases 2 protons. So if this is my concentration of acid, what do I have to do to get the concentration of the protons?
Divide by 2.
Each acid has 2 protons.
Oh, times
by 2. Okay, so I've realized sulfuric acid is diprotic, which means unlike hydrochloric acid and things like that, guys, when you're writing these equations, when you're doing these calculations, you guys know the step by step. You want to tweak it slightly for each nuance in the question, yeah? In this case, the concentration of the protons is 2 times 10 to the minus 5. So then I can trace my steps back. Notice how I'm tracing my steps. I did my equation. I got my proton concentration. Now I need pH. So pH is negative log base 10, 2 by 10 to the minus 5. And then just pop this in the calculator for me, guys, and correct me if I'm wrong. You get a pH of about 4.8. Just give me a thumbs up if that's correct, yeah? You get a pH of somewhere between 4 and 5. Thanks, James. So when you do that, you work backwards again. Tracing your steps for pH gets you to color. So then I look at my table. 4 and 5 gives me something purple. So for sulfuric acid, you should get a purpley color. Can I get a thumbs up, guys? Are we following that so far? If you have any questions, especially if you asked about this question, then let me know, yeah? All good? Great, thanks, guys. Okay, so that's for the acid, yeah? Unfortunately, you have to do the same thing for the base, okay? So now, it's not necessarily the same though. So for color, you need pH, which jumps you to the acid really easily because the acid releases H+, yeah? But what have we always said? If it's the acid, it's easier to calculate pH first. And somebody finish my sentence, if it's the base, it's easier to calculate what first instead? Erez?
POH.
pOH. So guys, for an acid, it's easier to calculate pH first because the acid literally has the protons, the base doesn't. So for the base, it's easy to calculate pOH first. So then working backwards again, you start off at color. Color links to pH, but pH doesn't link to the base very easily, which means from pH, you link it to pOH using the equation pH plus pOH is equal to 14. So you need pOH. Cuddy, what's the equation for pOH?
Isn't it like log, like the other way around? I don't really remember from last week.
That's okay. Justin, what's the equation for pOH?
Oh, is it not just the same? Just H minus?
Tell me what it is.
Minus log 10 OH minus.
Yeah, good. Thank you. So POH is negative log base 10 OH minus. So then working backwards from color, I need pH. From pH, I need POH. From POH, Justin gave us the equation. I need OH minus. From OH minus, it comes from the base. And the base in the question is NaOH. So I need the concentration of NaOH. But for me to work backwards, for me to link the OH minus concentration to the NaOH concentration, I need the equation. So same steps, except that you need to calculate POH first. So NaOH turns into Na plus OH minus. My concentration of NaOH is 5 by 10 to the minus 5. So Natalie, help me out here. What must my concentration of OH minus be based on this equation? Cody, your chance to redeem yourself. If this is my equation and that's my concentration of NaOH, what must my concentration of OH minus be?
Like, would it be the opposite? Oh,
What do you mean by opposite?
like,
That's all good. So Cody, stay on the mic with me, yeah? What's the number in front of NaOH? If there's no number, it must be a
like,
Hadia, help us out quickly. If there's no number in front, Cody, stay on the call with me, yeah? Hadia, if
Yeah.
there's no number in front, what's the number?
1.
1, thank you. Cody, so the number in front of NaOH is 1. Same thing for OH minus for me. There's no number in front, which means the number must be
1.
1. When you're trying to relate one chemical to another, I want you to look at the numbers in front, yeah? You start off with NaOH, you're trying to get to OH minus. So I want you to draw the arrow that way. I'm trying to transform the number in front of NaOH to the number in front of OH minus. The number in front of NaOH is 1. The number in front of OH minus is 1. So I just need to times by what? To keep it the same, I just times it by
1.
1. Yeah. So when you do that, when you figure out that ratio, you do the same thing with the actual number. Yeah. So I times the ratios by 1, which means when I have 5 times 10 to the minus 5, tell me, I times that by
1 and get the same thing.
So what's the concentration of OH minus?
5 times 10 to the power minus 5.
Good girl. Got it?
Yeah.
Okay, so guys, working backwards now, Cody helped us figure out the concentration of OH minus. I'm going to sub that back in here. And can you just pop this in the calculator for me quickly? I don't quite remember this one. 5 by 10 to the minus 5. What do I get for POH, please? James?
4.3.
4.3, thank you. Now, please, this is POH, okay? So I'm going to work backwards. All right. Also, Justin, you should keep doing that. I like it. James, you should reciprocate that. Yeah, that support is nice. So I'm gonna ask Justin a question later, and I need to see the same party hat coming from James. Okay. So we said I traced back my steps. Okay. So guys, if you're wondering like how the heck do I know what my steps are? Physically write out the backwards working out on your paper, okay? So you want to follow exactly what we've done here, and all you have to do is reverse the arrow the other way now. I got my equation, I got my concentration of NaOH, I've got POH now, I'm going to reverse backwards using this equation, POH plus pH is equal to 14. So pH is 14 minus 4.3, which gives me about 9.7. Working backwards again, I've gotten pH links to color. I go up here, that gives me blue-green, which is C. Can I get a thumbs up, guys? Does that make sense to us? Physically show the backwards working out on your paper, yeah? I've brought this up with you guys a couple of times. Until you get the ATAR that you want, you do everything it takes to minimize your mistakes, okay? You don't celebrate for too long until you get to the end of the year, yeah? Keep your head down, do what it takes to minimize your mistakes. Don't think that you're too good for that. Even if you are, okay? I know you are too good for that, which is why I'm telling it to you, because you're more vulnerable to that, yeah? Keep your head down until you get the ATAR that you want. Okay, so that's question 50. So I'm going to invite you guys to help me out with question 54, okay? Work backwards for me, yeah? Working backwards means that I start at what the question wants, okay? I start at what the question wants. Question 54 says, what mass of nitric acid will produce 2.5 liters of solution with a pH of 5.5? So Savan, what does the question want?
The mass of nitric acid.
Okay, good. So working backwards, I start at what the question wants. I need the mass of nitric acid. Working backwards, Noyo, what do I need to get mass? What equation do you know has mass in it?
N equals mass over molar mass. So
Thank you. Okay, the question needs mass. For me to get mass, I need moles. And then you can already tell, like just making a slight note here, you rearrange it to get moles. Mass is equal to moles times molar mass. Okay, so working backwards again, this is the equation that I'm dealing with. Okay, Samra, the equation that I'm at now is moles is equal to mass on molar mass. Which one do I need now? So working backwards, the question wanted mass. For me to get mass, I need moles is equal to mass on molar mass. I need to work backwards again, yeah? What do I need out of these three variables in the equation?
You need the moles.
You need the moles, good. What I meant by that, I didn't quite phrase that question well, but Samra got the handle of it. What I mean is, now that you worked backwards and you have moles is equal to mass on molar mass you get easily from the periodic table, so that's not your concern. So then you realize for me to keep on going, what I'm looking for that's unknown at the moment is moles. Okay, so working backwards, I realize I need moles. So Justin, I've already exhausted one equation involving moles. That's moles is equal to mass on molar mass, yeah? I need moles now, but I need a separate equation. What's that going to be?
C equals N on V.
Good. The next equation I might need is C is equal to N on V, and that'll give me my moles term. All right. Good, James. Thank you. Okay. Working backwards again, yeah? Daniel, my equation is C is equal to N on V. What variable do I need now out of this equation? So in this equation, let's go with Hadia. In this equation, working backwards, I needed moles. So that's what I'm already looking for anyway. So the two options you have left are concentration and volume. So which out of these two do I need, Hadia, to keep on going with my working backwards?
Concentration.
Concentration. Okay, similar to this equation, guys, molar mass I also need. Don't get me wrong. Yeah, I'm not saying you don't need molar mass. I'm saying what can you build on even more? Volume, I don't need to build on because it's given to me in the question. So working backwards, what I need is concentration. Okay. Remind me again, Cody, what was the question asking for? The mass of what?
Nitric acid.
The mass of nitric acid, which means, tell me, what concentration do I need? The concentration of?
Nitric acid.
Okay, good. The reason I bring this up, I know that was a bit of a weird question, but the reason I bring this up is because you guys analyze the question for me, yeah? What mass of nitric acid will produce 2.5 liters of solution with a pH of 5.5? With the information in the question, do I actually have the concentration of nitric acid? What do I have the concentration of with the information given to me in the question?
The proton.
The proton, good. pH is negative log base 10 of the proton concentration. So that's the reason why I asked Curdy that question. You don't get the concentration of the acid, but that's what you need. So working backwards again with your experience from the previous question, for me to get the concentration of the acid, I need to now, working backwards, I need to relate it to the concentration of the proton. And for me to get to the concentration of the proton, I relate it to pH. Okay, so now I've reached this point. Someone tell me, can I keep on going with my working backwards, or have I reached a point where I can start integrating the numbers from the question now? Have I reached a dead end? Can I build on it even further, or can I start subbing numbers in? Have a go. Don't be afraid, guys. You're so far away from your exams. I just need you guys to give it a go. Alright.
Maybe you could start subbing numbers in or write down a balanced equation first.
Yeah, good. I could do that as well. So for me to jump between the acid and the proton, I need the equation. That was the part they were missing. Thank you. Okay. James, neutralize the dissociation equation for nitric acid, please.
Is it HNO3
Hmm?
plus H2O?
Hmm?
And then there'll be a hydronium H3O
H3O what?
plus
Good.
plus NO3 minus.
Thank you. Okay, so I have my balanced chemical equation. I'm going to trace my steps back. I get to pH. pH is the 5.5 in the question. And working backwards, I'm using the pH to find the H plus concentration. So pH is negative log base 10 of H plus, which is 5.5. So then H plus is 10 to the minus 5.5. Cody, practice what you learned in the previous lesson, in the previous question for me, yeah? This is my concentration of H plus. Working
Yeah.
backwards, I'm supposed to get to my concentration of acids. Look at your equation for me. What must my concentration of my acid be?
Would it just be like 10 to the power of minus 5.5?
Good, well done. So it's 1 to 1 again. This time I'm jumping from the proton to the acid. So if it's 1 to 1, I times by 1. Do the same thing with this. My concentration of my acid is 10 to the minus 5.5. Well done. Okay, working backwards again. I've now got my concentration of my acid. I trace my steps back. I use the concentration of the acid to get moles using the C is equal to N on V equation. So N, because that's what I'm looking for, I'm tracing my steps back, is C times V. So that's 10 to the minus 5.5 molar times the volume they gave me in the question, which was the 2.5 liters. So that's just what I'll keep it as, because this is not proper scientific notation, but it's nicer to keep it that way. The number's not going to look very pretty. So now I've got my moles. Working backwards again, guys, your very last step when I trace it back. Now that I've got moles, I need to use the mass on molar mass equation to get the mass that the question wanted. So I've walked you back to your last step. You've got your moles now using your C is equal to N on V equation, working backwards for you to get to mass. You need to multiply that moles that you just got with the molar mass of HNO3. Can I get a thumbs up, guys? Does that make sense to us? Good, well done. For those of you, by the way, that aren't putting your hands up, I can see it each time, yeah? So if you're lazy, you got to tell me if you're lazy, because otherwise I'm going to think that you don't understand and I'll chase you up for it, okay? So just be attentive with that, yeah? All right. Apply this kind of thinking when you do the quiz today, okay? It'll help you out with all of your other questions. And I'm being serious, like with the face-to-face class is ahead of you guys and they're doing titrations, and I felt like I barely needed to do anything in class last week because they were getting the hang of this really well. Okay, pop open your quiz for me. For Savan and Aaron, you would have gotten it sent to your emails as well. We'll pop 15 minutes on this one. Some of you guys might get this done a lot earlier than others, so just pop it in whenever you're ready, but we'll put 15 minutes on this, yeah? So 6:57 to 7:07, 7:12. 7:12, we'll be back and we'll talk about what we're doing today, okay? over halftime, 5 minutes remaining.
One minute remaining.
Okay, let's get back into it. If you haven't already, submit your responses through. At this point, you have finished your first inquiry question for Module 6. You now need to know your common acids and bases. You need to know what they are. You need to know their formulas. You need to know their names. At this point in the course, you also need to know whether it's monoprotic, whether it's diprotic, as well as if they're weak or strong acids and bases, because that'll affect whether you do a double arrow or whether you do a single arrow. You also need to know what the indicators are, how they work, and that applies your things from Module 5. So you need to be able to apply your equilibrium theory from Module 5 to say that in an acid, the indicator goes this way, in a base, the indicator goes that way, and that's the reason why it shows a different color and even works as an indicator. Don't forget the experiment that you do to prepare a natural indicator as well, using your red cabbage or your blueberries, things like that. You need to know how to write your equations for acids and bases and apply that to examples in everyday life and in industry, and also do your enthalpy of neutralization calculations with your Q is equal to MCAT equation. You need to know why the Arrhenius theory and the Bronsted-Lowry theory are good and bad, and write a short answer response for that. Remember, those are one of the things that you can prepare, get a full mark response for, and just leave it to the side until it gets to the exam, because the questions for that don't vary very much. You need to know your basic pH calculations, which we covered last week. That was what you were assessed on. And you need to know what the pH of an acid and what a base are. pH of acid is generally less than 7. For base is greater than 7. If it's neutral, it's equal to 7. You also need to be able to rearrange the pH equations to calculate the different concentrations as well. And at this point, from the very end of last lesson, you know what it means for something to be amphiprotic and to write the balanced equations for those. And just glancing at your quizzes, you need to be very careful about what you're writing, yeah? Some of you guys know what amphiprotic means, but you write the equation for a different chemical. Just watch out for that. We're going to finish off the second inquiry question today very quickly with models and diagrams about the difference between strong, weak, concentrated, and dilute acids and bases. That won't take us very long. It's just a couple of drawings. And what will take a little bit of time is pH when you mix or when you dilute acids and bases. So last lesson, you got introduced to your basic pH calculations, just a standalone acid, just a standalone base. And now you're going to deal with what happens when you add a little bit of extra water to dilute it. That one's a little bit simpler. And you're also going to work with what happens when you mix the acid and the base together and they start neutralizing each other. How does the pH change then? Remember, once again, the calculations that we start off with are strong calculations. So when we go to do this, in a couple of minutes, you'll notice that might be challenging, but it's a nice step-by-step, yeah? And I remind you again, do take note of the step-by-step. If you dare skip any of the steps and then you struggle with weak calculations, I'm going to struggle to tell you, I told you so. Okay, I won't do that. I won't actually do that. But just keep that in mind, yeah? Don't skip any of the steps. I'm just here to try to make your life later on a little bit easier. Okay? All right. Before I scare you with that though, Nessa wants you to know what the difference between strong, weak, concentrated, and dilute is. So, Aaron, what's a strong acid or what's a strong base?
They're substances that fully ionize.
Yeah, weak acids and weak bases ionize too, but what's the difference?
Strong acids usually are fully ionized, whereas weak acids partially ionized.
But thank you. So strong means that it dissociates or ionizes completely, and then weak means that it does it partially. And then, Hadia, what does it mean for something to be concentrated versus dilute?
Concentrated has a higher amount of the particle.
Yeah, so concentrated means that there's lots of moles of it in there. And then what does dilute mean?
it has less moles in it.
Yeah, and a bit more volume. Good. So concentrated means that there's a lot of it in there, and diluted means that there's less moles in the volume. Okay, so strength has to do with how much it dissociates, whereas concentration has to do with how much is in there, regardless of if it's the molecule that hasn't dissociated or the ion that has dissociated. Okay, so I want you to keep this in mind with these two definitions here. This has to do with strength, and this has to do with concentration. Strength and concentration are independent. Strength just has to do with, does it fully dissociate? Does it not? Concentration just has to do with, is there a lot of it in there or is there not a lot? So what Nessa wants you to know, and what they don't want you to get confused, is that just because something's strong doesn't necessarily mean that it's concentrated, because you could have hydrochloric acid, but there might only be 1 mole of that in the volume, in which case it's not concentrated, it's dilute. But Nessa also wants you to know that you could have something weak like acetic acid, but it could be really concentrated, which means pretty much all of your beaker is made up of acetic acid and there's not that much water in there. So you can have concentrated and weak, and you can have strong and dilute, and you can draw diagrams for all 4 combinations of these. So what I want you to keep in mind is when you're drawing these diagrams or these models, let's just say we have a beaker. All concentrated means, okay, concentrated just means that you have a bunch of stuff inside of your beaker. And then dilute just means you only have a few things in there. And what those things are, like what formulas you actually write inside of your bubbles, depends on if it's strong or weak. So remember, concentrated or dilute just means, do you have a lot of bubbles in your beaker representing the chemicals, or do you have just a few? And whether it's strong or weak depends on what you put inside of those bubbles. So, Noyo, if something is strong, like hydrochloric acid, do you expect to see the hydrochloric acid molecules in there, or would you only see the ions that it turns into?
Only the ions.
Only the ions. So when something's strong, it dissociates completely. So you would only see the ions. Like if it was HCl, if you're drawing a diagram for HCl, you shouldn't have a bubble with HCl in it, because that means it hasn't dissociated. So in that case, if they want you to draw a diagram for hydrochloric acid, you should only have H plus and Cl minus inside of your bubbles. Things like that. And then if you had something like HCN, you guys haven't, I've shown you this once or twice before. HCN is hydrocyanic acid and it's weak. So if it's concentrated hydrocyanic acid, I have a lot of bubbles, but because it's weak, I'll turn this into CN minus. And because some of it is weak, not everything breaks apart. So because not everything breaks apart, I'm actually going to replace some of these ions in here with HCN bubbles, because it hasn't fully broken apart yet. Okay, so I want you to keep in mind, if it's concentrated, there's lots of bubbles. So just draw the bubbles in first without putting in the formulas, because that starts confusing you a bit. If it's concentrated, lots of bubbles. If it's not concentrated, very few bubbles. If it's strong, you only write the ions with the charges in there. And if it's weak, you should see some of your molecules in there as well. Can I get a thumbs up, guys? Does that make sense? Concentration and strength are independent. If it's concentrated, lots of bubbles. If it's not concentrated, only a few bubbles. What you write in those bubbles depends on strength. Yeah, so do those separately. So then, Samra, help me out here. If I want to draw a model for a weak, oh, that's not what I'm looking for. I want to draw a model for a dilute NH3 solution. So concentration is given to you, it's dilute. NH3, you have to help me out with that. Is NH3 strong or weak?
Would that one be strong?
NH3 is a weak base. NH3 is weak. So let's start off with dilute. I have my beaker. If it's dilute, do I have a lot of bubbles or do I just have a few bubbles?
A few.
Yeah, I only have a few. So let's just do 1, 2, 3. And if it's weak, do I only see ions in there or do I see the molecule itself as well?
You would see the molecules itself.
Good. Because if it's strong, guys, it dissociates completely. You would only see the ions. If it's strong, it dissociates completely. You only see the ions. But because NH3, ammonia, is a weak base, I would recommend writing it in first, just so you don't forget it. So NH3 is a weak base. And Elena, what does a base do again? Does it take a proton or does it give a proton? Yeah, a base takes a proton. So if I had water, it would take a proton. So then NH3 would turn into NH4 plus, and then water would be left as OH minus. So these are the ions that I want to put in. So this would be NH4 plus, and this would be OH minus. So this, guys, is your weak and dilute base. And then, Curdy, if I wanted to make this concentrated instead of dilute, what would I just do?
Just add more of the solution.
Yeah, I would just add a bunch of more bubbles in. So now I do NH3 here, OH minus here, NH4 plus here, and then same thing one more time. Okay. Can I get a thumbs up, guys? Does that make sense? If it's concentrated, lots of bubbles. If it's dilute, less bubbles. If it's strong, you only see the ions. If it's weak, you see some of the ions, but you got to make sure you put in some of the molecule in there as well. All right, good. Any questions, please remember, type it in the chat or unmute yourself immediately, yeah? There are 4 different cases for this. You can, actually, there's like 8 cases for this. So you can do it for a base, strong concentrated, strong dilute, weak concentrated, weak dilute. You could do it for an acid, same thing, strong concentrated, strong dilute, weak concentrated, weak dilute. So there's 8 variations that the exam could ask you for. So if you want to know most of them, I don't think I have all of them in here, read pages 27 and 28. This one is concentrated, strong and weak acid. This one is concentrated strong acid and dilute strong acid. And in your example in the notes is strong concentrated base and dilute weak base. So there are a few variations of this. If you want to consolidate that, have a read of your notes for me. But all we want to make sure is that you know that they're independent. Yeah, just because something's dilute doesn't mean it's weak. It could be strong. And just because something's concentrated doesn't mean it's strong. It could be a dilute acid or base. All right. Now, so this is all you're expected to do. It's your diagrams, yeah? When you go to do the actual diluting or mixing of the acid and the base, there are step-by-step calculations that you could do for this, okay? So we'll start off with diluting first. When you're diluting something, all it means is that you've added more water to it. So concentration is C is equal to N on V. Diluting means that you've added more solvent, which is usually water. So you increase the volume and you decrease the concentration. But Shiv, when you're diluting something, does the moles change?
Yeah.
So we just said that diluting is when you increase the volume and you decrease the concentration. Have we said anything about moles?
No.
No. So does moles change when you're diluting?
No.
No. Guys, when you're diluting, all you're doing is you're keeping the same solution, you're just adding more water to it. So the amount of chemicals in there stays the same. There's just less in the bigger volume. So there's less per unit, which is what concentration is. But in a total quantity, the same number of moles is still inside of your beaker. Yeah. This is the equation that you know from year 11 for dilution. C1V1 is equal to C2V2. This equation only works if all you're doing is diluting. It only works if all you're doing is diluting, which is all that you did in year 11, okay? But now that you're in year 12, I don't think we've seen too many questions. You see them more in module 6. You'll see them soon. But there's been 1 or 2 questions that we've done where it's like, oh, you dilute it to like 1 liter. But then if you guys remember, give me a thumbs up if you remember this when I say it, yeah? Like the question says, oh, I'm diluting it, I'm adding a bit more water, it turns to 1 liter. And then the second sentence says, and then instead of taking the 1 liter, I only take like 100 mils to do whatever I want to do with it next, yeah? That's no longer dilution. You've diluted it, but then you've changed the number of moles in the next step because you've started dividing up the volume. That's why I'm gonna let you know this equation anyway. But this equation only works if the only thing you're doing is diluting, because the moles don't change. But then what you see more of in year 12 is, oh, I'm diluting to 1 liter, but then I don't take my diluted solution, I take my 1 liter, and then when I go to do something else with it, I only take 100 mils of it. If I only take 100 mils of it, my moles has now changed. So trying to do it by the equation gets a little bit messy, yeah? So when you get questions on diluting, when you notice things changing volume, what I prefer to do is keep track of the number of moles over time and then just divide it by the final volume at the end, because then you can get the final concentration and then you don't have to worry about what happens to moles each time, yeah? So this is your equation for dilution. C1V1 is equal to C2V2, but it only works if all you're doing is diluting, which worked in year 11, but in year 12, it doesn't anymore. Okay, so when you're looking for pH, you know pH is negative log base 10 of H plus. So if the question says, oh, what's the pH after diluting, you know that you need to find the concentration after it's done diluting, after the volume's done changing, and then just pop it back into your pH equation. Yeah. So this here is the step-by-step for diluting, but you'll notice that I'm not paying too much attention to it because the questions that you get in year 12, they won't just use that equation. You'll need to keep track of the moles over time. So it's easier to do it that way. So it's better to look at it through a question. Natalie, do you mind having a read of 77 for us, please?
A 20 milliliter volume of 0.10 moles per liter of nitric acid solution is diluted to 100 milliliters. What is the change in pH for the nitric acid solution of this dilution?
Thank you. Okay. Working backwards, they're asking me for change in pH. That's where I want to end up. Change in pH isn't just the final pH. Change in pH is pH final minus pH initial. So I need both, okay? But generally, I know that I need pH. I'll divide it up into the final and the initial afterwards. They're asking me for change in pH. I need pH for the final and pH for the initial. Working backwards, pH is negative log base 10 of H plus. So I know that I need H plus. Working backwards, the question doesn't give me information for H plus. The question gives me information for the acid that produces the H plus. So working backwards, I realize I need the concentration of HNO3 as well as your chemical equation. Okay, so you'll notice I'm doing my backwards tracing a little bit faster now just to get you guys used to it, yeah? But if someone feels like it's still a little bit too fast, just pop a message in the chat so I know to slow down a bit, yeah? But you guys have been exposed to this a little bit now. So this is my general process. You guys are familiar with this because it kind of just looks like a regular pH calculation. The only difference is I do it twice to get the final and to get the initial, and then I calculate the change. Okay, so I'm going to start with the initial first. The question tells me that a 20 mil volume of 0.1 molar nitric acid is diluted to 100 mils. This is final, yeah, because that's where I end up. I don't want to worry about that yet. This is what I start off with. This is my initial. So that's just all I'm going to do. So I'm going to trace my steps back. I start off with my equation. So that's what I'm going to do. Samra, what's the equation? What's the dissociation equation for nitric acid? Arez, what's the dissociation equation for nitric acid?
HNO3 aqueous plus H2O liquid. And then it's a strong acid, so the one arrow. NO3 minus aqueous and then H3O plus aqueous.
Good. Thanks, Arez. Guys, I want you to pay attention to how Arez always includes his states in the equation and he doesn't rush when he's answering the question, yeah? I notice some of you guys are starting to get a little bit nervous now that school is starting up again. I'll emphasize you're not anywhere near your HSC exams. You have 9 months of it left. Take as much chance, take as much opportunity to make as many mistakes as possible, yeah? So if you feel like, oh, I'm going to get this question wrong, that's the point. I kind of want you to get it wrong because I'd rather you get it wrong now than later, okay? And Arez reasons his way to the answer very well. So there was no rushing there. He told me it's a strong arrow, so it's a single, it's a strong acid, so that's why we use a single arrow, those kinds of things. Get in the habit of saying things like that, yeah? Okay, so that's my HNO3. My concentration of HNO3 at the start is 0.1 molar. Savan, working backwards, I've got my concentration of HNO3. What's my concentration of the protons on this side?
It's the same, so it's 0.1.
It's 0.1 as well. Good. Working backwards again, I sub that into my pH equation. Negative log base 10 of H plus, which is negative log base 10 of 0.1. If you guys sub this in your calculator, this should give you 1, if I remember correctly. Just give me a thumbs up if that's correct. I think that was right. Yeah, okay, thank you. Okay, so now I've got my pH for initial. I do the same thing for my final. So, oh, hold on, other one. Now I need my final. The only thing with my final is I need to go looking for my HNO3, okay? So remember, guys, what we said in this case, by the way, question 77, the dilution equation works because that's all is being done in this question. After they told you they diluted it, there was no extra sentence about what happened. So technically you could use the dilution equation for this, but it doesn't work every time. So I'd rather get you in the habit of tracking the moles, yeah? So the moles of HNO3 doesn't change, it's the volume that changes. So I'm gonna keep track of the moles. What formula do I use to calculate moles, given the information in the question? Question gives me concentration, question give me volume. So Samra, what's the suitable equation?
N equals to C times V.
Good, N is equal to C times V. So the moles comes from the solution at the start, the 0.1 molar, and the initial volume that they use to do the diluting is the 20 mils. So that's 0.02. So that's going to be 0.002 moles. So now that I'm keeping track of my moles, I need to watch out for if the volume changes at all. I've diluted it to 100 mils, but there's like no dividing afterwards. They don't say I take 100 mils and then I only take 10 mils in the next sentence. So I don't have to worry about this 0.002 moles changing. So I'm confident that that's my final moles and I can use it to calculate my final concentration. So HNO3 is moles on volume, 0.002 moles. Now that I'm at my final concentration, I've got my final moles and I need my final volume, which was the original 100 mils, which I take as 0.1 liters. And that gives me 0.02 molar. And then I trace my steps back up. So I got my HNO3 concentration again, working backwards. I need to get to my H plus concentration or my H3O plus concentration. Some of you guys were getting a bit confused as to why we write the dissociation equation like this to include the H2O. If you write your equation like this, all you've shown is that HNO3 can produce a hydrogen ion in solution, which is what an Arrhenius acid does. Yeah, but a Bronsted-Lowry acid, not only does it produce the hydrogen ion, it donates the hydrogen ion to the base, which is why we include the water in here. James?
Why is it 0.1 liters for the volume?
Yeah, cool. So initially, the question asked us for change in pH, so we needed the initial pH, but change in pH means that we need to take the final pH as well to calculate that change. And the final pH comes from the final solution. And from the question, the final form of the solution exists in a 100 ml volume, which is 0.1 liters. So that's my final volume that HNO3 exists in. So I use that to calculate my final concentration. Does that make sense?
Oh, yeah. I thought it said it added 100, not it
That's
goes
it.
to 100.
Yeah, so some of you guys were confused about this earlier. If you write your equation like this, that's an Arrhenius acid, which is completely fine. Like, it works for your stoichiometry's sake. But if you include the water and you show the proton going that way, that means that it's a Bronsted-Lowry acid, because not only did it make the H+, it gave the H+ to something else. So just give me a thumbs up if that makes sense, guys, because some of you guys had that concern at the start. Yeah? Okay. So same thing, my H3O plus concentration is now 0.02, trace my steps back, pH is negative log base 10 of 0.02. If you do this and you pop it in the calculator, you would get 1.7. So my initial is 1, my final is 1.7. So your answer for this question is A. In this case, they just asked you for the start to the end, but if they actually asked you for the change, then it would be 1.7 minus 1, and the change would be 0.7. Can I get a thumbs up, guys? Does that make sense to us? Keep track of the moles until you get to the end, and then take the final volume, yeah? If you want, feel free to experiment with the dilution equation. You'll see that you get the same answer, because 77 is very straightforward. But 78, which we'll do now, you'll notice that the dilution equation works fine, but then you'll have to do some additional steps afterwards, and it's just not as fun. Shiv, can you read 78 for us, please?
Nitric acid completely dissociates in aqueous solutions. 1 milliliters of 10 moles per liter solution was diluted to 1 liters with distilled water. 100 milliliters of this resulting solution was then further diluted to 1 liter using distilled water. The pH of the final solution is closest to.
Thank you. Okay. Watch out for these moving forward, yeah? Next lesson, we're going to start on titrations. And then the lesson after that, we're doing back titrations. And this is where you start seeing it more often. So this change in volume stuff, be very, very careful of it, okay? When one sentence ends with a bigger volume than the next sentence starts with, that's a red flag, okay? That's Nessa trying to do unnecessary stuff to give you a bad time. Okay, you just want to watch out for that. Same thing, keep track of your moles until you get to the end. Okay, so read the question from start to end. So we just read it one by one. Nitric acid completely dissociates in aqueous solution. There's nothing there. And then in the second sentence, it says 1 ml of 10 molar solution. This is where I start. So I'm going to calculate my initial moles. Is equal to 10 mole per liter times 1 mil, which is 0.001 liters. That'll give me 0.01 mole. Okay. And then it says that was diluted to 1 liter in distilled water. So this 0.01 moles is in the original 1 mil. Keep track of your volume. And then when you dilute it, Shiv helped us figure out earlier that when you dilute, all you're doing is changing the volume, you're not changing the moles. So this is the same as the 0.01 moles in the 1 liter. Can I get a thumbs up, guys? I just want to make sure you're keeping track of this. Yeah, when you're diluting, you're not changing moles, you're just changing volume. So after I calculate the original moles, that is the same moles that's in the new volume, because all I've done is dilute. Okay, it's only when I go to the second sentence, 100 ml of this resulting solution. Now I've started dividing the volume. So I'm going to go, this is 0.01 mole in 1 liter. I'm trying to get to 100 mils. I need to scale down. So 1 liter is 1,000 mils. How do I go from 1,000 mils to 100 mils? What kind of maths am I doing? Samra?
Dividing
By?
by 10.
Yes, good. Dividing by 10. So originally I had 0.01 moles in 1 liter, which is 1,000 mils. The second part of the sentence tells me that they only took 100 mils, which means what they must have done was divide the volume 10 times. So if they divide the volume 10 times, thanks, Daniel. If they divide the volume 10 times, I do the same thing with the moles. Divide by 10. So then I get 0.001 mole in 100 mils. This part here, you can't do with your dilution equation. This part you could. Yeah, that part you could do with your dilution equation because that was what it was. But when you go from 1 liter to 100 mils, that's not diluting. So there's no equation for that. So when you get questions that involve diluting as well as dividing up the volume, it's easy to just keep track of it because then you just have the same process each time. Because otherwise you'd have to use C1 V1 is equal to C2 V2 here and then switch your method afterwards. It just gets a little bit messy. So we'll just keep it like this. So now you've got 0.001 moles in that 100 mil. Let's see what they do with that. The 100 mils of this resulting solution was then further diluted to 1 liter using distilled water. So this went to 1 liter, but because they used the word diluting, that means that all they did was add water. So Savan, has our moles changed?
No.
No, good. Because when they use the word diluting, they're just adding water. The moles has not changed. So the 0.001 moles in the 100 mils is the same as the 0.001 moles in the 1 liter. Okay, let's keep on going. Was then further diluted to 1 liter using distilled water. And then the next sentence is the pH of the final solution is closest to, which means I've gotten to the end of my scenario. There's no more volume changes. There's no more mole changes to keep track of. This is my final moles. This is my final volume. So I can go ahead and now calculate my concentration. So concentration of the acid, HNO3, you can write out the equation again. It's this equation here. The concentration of the acid is N on V, which is 0.001 on 1, which is just 0.001. And then based on that equation, it's a 1-to-1 ratio with the protons. And my only job now is to sub it in to my pH equation, which gives me 3. Can I get a thumbs up, guys? Does that make sense to us? Feel free to experiment with it the other way. You guys know that I don't like to tell you exactly what to do. I'm passionate about the advice that I give, but it's also nice to get some fight back, okay? I don't talk about this often. I think some of you guys know at this point, but it's a bit more important that you develop the thinking skills that's necessary. I bring that up quite a bit. Memorizing your steps only takes you so far. I'm not just talking about school, I'm just talking about afterwards as well. You need to be able to think for yourself and reason your way to things. So if you don't like the way it's done, experiment with it your way, figure out what works for you. Yeah, it's not just about the way you're taught. Just wondering why the 0.01 moles changed after taking 1 liter. How come taking smaller samples changes moles? So when you're at this point, the 0.01 moles in 1 liter, that was the end of the first sentence. And then in the second sentence, so at the end of the first sentence, you have 1 liter. At the start of your next sentence, they tell you that of this resulting solution, they only took 100 mils. When you go from a small volume to a big volume, you only have to add water, which means it doesn't change what's already in there. But when you start dividing up your volume, when you go from a big volume to a small volume, 1 liter to 100 mils, you cannot do that without taking out the moles. Because the moles is mixed everywhere inside of the beaker. So you can't scoop out 100 mils and expect that to just be water, which is why when you scale from 1 liter to 100 mils down here, you have to scale your moles proportionally. So that's like saying if I had like, I don't know, 3 plastic balls in a bucket and I poured some water into it, I can pour water in without affecting the balls in here. But if I try to start scooping the water out, there's no saying I'm just going to scoop the water out. What if I accidentally scoop a ball out? That changes my mole. So that's why I have to scale it proportionally. Let me know if that makes sense. No, good. Okay. All right. That is your diluting your moles. Your mixing your acid and base is going to take a little bit more work. There are steps by steps. I'm going to move away from that in true class fashion. You guys are used to that already. Okay. You guys probably don't even expect it anymore. Just give me a thumbs up if that makes sense. You guys see the step and just like, whatever. We're not going through that first. Okay, so we're gonna move to the side. Yeah, we're gonna move to the side. Okay, you guys know that, right? It's not even surprising to you anymore. All right, read those steps whenever you like. We're gonna reason our way backwards. So you've never seen this kind of question before, but that's the whole point. The reason why we keep reasoning our way backwards is so that when you go into the exam and you see a question you've never seen before, you can confidently feel like you're doing it the right way. So it's really good. Like, I know how to do this question, yeah, but you're going to reason the way with it with me. And then at least you have someone that can actually tell you, yeah, you're on the right track, because you can't do that in the exam. But practice makes perfect. Okay, so the question is this, yeah? We're moving on to your mixing acids and bases now. The scenario is the question wants you to find the pH. So let's write out the whole question. Let's go, what is the pH after mixing? They normally say resultant solution, but I'm going to keep the wording simple because it's your first time seeing it, yeah? What is the pH after mixing 50 mils of 0.15 molar HCl and 25 mils of 0.35 molar NaOH? Okay. Noyo, when we're working backwards, I start at what?
What the question's asking for.
Thank you. When I'm working backwards, I start at what the question's asking me for. So what the question's asking me for is pH, okay? Now, what do I need to get pH? Shiv, what's the equation for pH?
This is the log one.
Yep, what's the
Yeah,
pH?
negative log 10 and then proton.
Yeah, negative log 10.
H plus. Bracket.
What does the bracket mean, mate?
The proton.
What about the proton?
pH.
Guys, what do the brackets mean?
Concentration.
Concentration, thank you. You knew that. I know you know that, Shiv. I just want you guys to be clear with your wording. Yeah, you knew that. I know you know that. So pH is negative log base 10 of the concentration of H plus. So let's just challenge ourselves to communicate that a bit clearer. I know you guys know it. That's all I'm doing here at this point. Yeah, I've noticed that too. Like with the face-to-face class, there are students in there that I know they know what they're doing, but I don't know why you guys are hiding it from me, okay? Don't feel shy to show off what you know, okay? I'm gonna call out that person in the face-to-face class soon, because he's smarter than he lets him out. And you guys are the same, okay? Don't be afraid to bring this stuff up. pH is negative log base 10 of the concentration of protons. So then I'm like, what I need next is the concentration of the proton. So help me out, guys. Where do the protons come from? Because I don't get protons in the question. So I can't stop here. I need to keep on going. Where do the protons come from?
Balanced equation.
There are different equations I can write. What equation am I writing? You're on the
Maybe
You're on the right track. Like for me to relate the proton concentration to something else, I need the equation to relate it. But what am I relating it to, James?
The neutralization reaction,
Build on that a bit for me.
the acid-base reaction.
Yeah, why? Build on that a bit more.
What do you mean?
Well, you skipped a few steps. Like you're right, by the way, we have to get to that neutralization reaction, but I want to see if you can explain it to the class. Where do the protons come from? The neutralization reaction doesn't make the protons. James knows where he's going, but I'm going to challenge you guys to reason your way to it a bit better. Where do the protons come from? Simple question. Arez.
the acid.
The acid, thank you. The protons come from the acid. All right. Now, this was what James was getting at, yeah? Not every proton that comes from the acid affects the pH. Why, James? Because not only is there acid, there's also what in the question?
There's hydrogen in the base.
The sodium hydroxide, which is the base. And what
Yeah.
do the acid and the base do?
React.
React in what kind of reaction?
Neutralization reaction.
Neutralization. Thank you. I knew that's why I asked you to get a bit deeper with the explanation. You can't jump that far because everybody else won't get it, yeah?
Okay.
You've got it. I know you know what you're doing, but I need to get everybody else on board. What Noyo helped us figure out, when we're working backwards, you start at where you want to end up. pH is where you want to end up. Working backwards again, I don't have enough information to get pH straight away, so that's when I keep on working backwards. Yeah, guys, so your indication to keep on working backwards is that you don't have enough information to work forward yet. So pH, I don't know pH. I need to work backwards. pH is negative log base 10 of H+. I need H+. I don't know H+. I work backwards again. H+ comes from HCl, which kind of seems like I can start tracing my steps back because technically I do have a number I can put in. The only issue is though, the question doesn't ask you for the pH of the acid. The question asks you for the pH after mixing the acid with the base. So the issue is this, yeah? The pH, the concentration of the protons comes from the concentration of the acid or the base. Because remember, from the base, you can calculate pOH, which then you can convert to pH, yeah? So the pH comes from the acid or the base concentration, but not the acid or the base that's in there. The acid or the base that's left over after the neutralization reaction. I'm going to explain this one more time before I ask for a thumbs up, yeah? pH comes from the negative log base 10 equation, or you could also get it from pOH. It depends on what's left over, okay? So pH, the way you calculate it, whether or not you go this route or whether or not you go that route using the pH plus pOH equation, depends on whether or not it's the acid left over or whether or not it's the base left over. This isn't as simple as your straightforward question, because with the straightforward question, the only thing that affects pH was whatever they gave you, the acid or the base. In this case, because they've given you both, the acid and the base cancel each other out to produce something neutral that doesn't affect pH. That's why it's called a neutralization reaction, by the way, yeah? It's called a neutralization reaction because the acid and the base cancel each other out, produce something neutral that doesn't affect pH. So your job is to figure out whether it's the acid or the base that's left over, and then you can follow your regular pH calculations afterwards. Can I get a thumbs up, guys? Does that make sense? It's not just about how much you've added, it's about how much you have left over, because only the acid or the base left over affects pH. Because if some of it gets reacted, it turns into something neutral. It doesn't affect pH anymore. Okay, so that was sort of the missing gap. We've never dealt with something like that before, yeah? But now that I've bridged it for you, you guys can help me keep on going, okay? So we said it's not just the it's not just the concentration of the acid or the base, it's the concentration of the acid or the base that's left over. Working backwards again, I don't have enough information to do that, so I need to keep on going. So guys, what's the next step? Or what's like the previous step if I'm working backwards? How do I figure out what's left over? James?
Chemical equation.
I need a chemical equation. What else do I need? Left over is excess. The opposite of excess reagent is the
Limiting.
limiting reagent. Good. So what's left over is the excess reagent. For me to know what's in excess, the inverse of that is I need to know what's the limiting reagent. So basically, guys, what you're doing is a limiting reagent calculation first to figure out whether it's the acid or the base left over, and then you do your pH calculations as usual. So working backwards, I need my concentration of acid or base that's left over. For me to know what's left over, I need to know what the limiting reagent is. For me to know the limiting reagent, I'm gonna fill in a few gaps. For me to know what's left over, that's the excess. For me to know what's the excess, I need to know the limiting reagent. For me to know the limiting reagent, I need to know the moles of the acid and the base that are reacting together. And then in combination with that, I don't just need to know the moles, I need to know the ratio in which they react. And the ratio I get from the chemical equation. Okay. Take a second to jot this down. If you're confused, I ask that you just forget about it quickly, and then we'll go through it one last time from the start, yeah? The question is, what is the pH after mixing 50 mils of 0.1 molar HCl and 25 mils of 0.35 molar NaOH? When you're working backwards, you start at where you want to end up. I want to end up at pH. Working backwards, there are two ways of calculating pH. pH is negative log base 10 of H+, which means I need the H+ concentration and I need the HCl concentration. The other way of calculating pH is pH plus pOH is equal to 14, which means I need pOH, and pOH comes from the base concentration. So I take this route if there's acid, and I take this route if there's base. So for me to figure out which route I take, which route I take, whatever. You guys let me know which way you say it. Which route I take, it depends on which one's left over. Okay, so this is yeah. So normally when you guys work backwards, there is only one way of doing it. Now you have to figure out which path you take. This is sort of like an if statement in coding. So for me to figure out which route I take, I need to figure out which one's left over, the acid or the base. So that's my next step. For me to figure out which one's left over, aka for me to figure out the excess, in turn, I need to know the limiting reagent. For me to know the limiting reagent, I reflect on my calculations from year 11. For me to know the limiting reagent, I need to know the moles of the things that are reacting together. And I need to know the ratio at which they react. And the ratio at which they react comes from the chemical equation. And then once I get to the chemical equation, there's nowhere else I can build on anymore. I just need to know the formulas, and then I can write out the equation, and then I can start tracing my steps back. Can I get a thumbs up, guys? Does that make sense to us? If you're a bit confused, it'll come somewhere from here, yeah? There are two different ways of doing it. So if you're a bit confused, and oh, and by the way, some of you guys I check in on, and I think we've noticed that I think that you might be able to identify that you're confused, but not necessarily where, yeah, which is completely fine, by the way. That's no issue at all. even if you're confused and you don't know where, I want you to communicate that with me anyway, yeah? Because what we'll do in that case is I'll get you to talk to me about what you feel like you know. And then from there, I'll see what your thinking's like, and then we can figure out where you're confused, even if you feel like you don't know where that is, okay? So I want you to keep in mind, even if something's bugging you, but you don't know what it is, communicate that with me anyway. We'll be able to figure it out, okay? So we're tracing your steps back. This is your step, okay? So I'm going to read this to you and you can realize it's exactly what we talked about, all right? So step 1 is to write that balanced equation. Step 2 is to calculate the moles of the protons from the acid. Step 3 is to do the same thing, but for the hydroxide for the base. Step 4 is to figure out which one's in excess. Step 5 is to calculate the final volume so that you can calculate the final concentration. And then once you calculate the final concentration, you can go ahead and calculate pH, whether or not that's using the negative log base 10, or whether that's using pH plus pOH is equal to 14, okay? So these 7 steps here is your right way, or is your forward way if you trace back these steps that we just did, okay? All right, so balanced chemical equation. Natalie, keep doing this, guys. We're reacting HCl with NaOH. Can you write out the balanced equation for us? What would that be?
Sorry, could you repeat the question again?
Yeah, we're writing the balanced equation for HCl and NaOH. Can you help us do that? What would the chemical equation be? Hadia? HCl plus NaOH?
So it would be
Go on.
NaCl.
NaCl? Salt plus?
And water.
Water. Good. Salt plus water. Well done. Okay. All right. So that's my first step. I've got my chemical equation. Then I need to know the moles of the acid and the base reacting together. I'm going to jump straight to the moles of the protons and the hydroxides that get made. So moles of hydroxide, it's a 1-to-1 ratio with the acid. So that's moles of HCl. And then Aaron, the information they've given me for the acid and the base is volume and concentration. So what kind of formula am I going to use to calculate moles?
You use the number of moles equals concentration times volume.
Good. C times V, which is 0.15 molar multiplied by 0.05 liters. Can someone pop that in the calculator quickly for me, please? We do the same thing for the base. Uh, 0.0075. Thank you. And for the base.
0.00875.
Thank you. 0.00875. So I jumped straight to the H plus and the OH minus, so I don't have to worry about the ratio in the equation. I know that the H plus and the OH minus react in a 1-to-1 ratio anyway. So I've got my equation, I've got my moles that are reacting together. Now I need to figure out my limiting reagent. So it's a 1-to-1 ratio. H plus OH minus turns into H2O. So this is the overall equation, but then when you break it down, it's this particular component of the acid and the base that react together. So this is always a 1-to-1 ratio. So the limiting reagent is just a smaller number, yeah? So Savan, looking at this, 0.0075 for H plus, 0.00875 for OH minus. What's your limiting reagent?
The moles of hydrogen ions.
Yes, your limiting reagent is H plus. So help me out again. Your excess reagent must therefore be?
The moles of hydroxide ions.
Yeah. So your H plus is your limiting reagent because it's smaller. So OH minus must be your excess. So I figured out my limiting reagent. I figured out my excess. Now I go to calculate concentration. So concentration of OH minus is moles on volume. But guys, this is the moles that's left over. Yeah. Remember, this is the amount that I put in. H plus completely reacts together to turn into the stuff on the right-hand side. So how do I calculate the amount of OH minus that I actually have left over, that's in excess? What do I do? These two are the amount I added. I want to know how much is left over. Hadia?
You subtract the 0.00075 from the 0.00875.
So guys, when I did this calculation at the start, I want to emphasize this is the amount that I put in initially, yeah? When I go to calculate pH, we already agreed earlier that pH is affected by the thing that's left over. So I need to do how much I add minus how much gets reacted with the other thing to figure out how much is left over. Can I get a thumbs up, guys? Does that make sense? This is in excess, yes, because I added more of it, but it's not 0.008 left over. It's 0.008 that I added minus however much gets used up. Yeah, minus however much gets used up. I want to emphasize that. Okay. So follow this with your calculator for me. This gives you 0.00125. So that's my moles that's in excess. So I figured out what the excess was, but remember, I need to figure out the moles that's in excess. This is the excess reagent, but I need to figure out the mole that's in excess. Working backwards, I now go to calculate the concentration. So concentration of OH minus is moles on volume, which is the 0.00125 moles, divided by the total volume now, because I've mixed the two solutions together. The volume is 0.05 plus 0.025 because I've mixed the two together now. Okay, it's not just one volume anymore. 0.05 plus 0.025 liters. What's my concentration, please?
Zero 0.016 and then just keeps repeating 6.
Thank you. Keep that stored in your calculator. Okay, I've got OH minus. Justin, help me out. Because NaOH, because the base is in excess, which way do I go to calculate pH? Number 1 or number 2?
Number 2.
Number 2, good. So guys, I can't use the pH equation straight away because I actually don't have the H plus because all the H plus got used up. So because I have, remember, if I have a base, I calculate POH first and then I calculate pH. All right. So I need POH. Shiv, what's the equation for POH?
POH equals negative log 10. Yeah, bracket H plus.
Bracket.
OH minus.
Bracket OH minus, good.
Yeah.
Look at you, saved yourself. Negative log base 10 of 0.016, da 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 da. So what's POH? James?
1.778.
1.778. Keep all of the numbers in your calculator. And then for me to convert to pH, it's POH plus pH is equal to 14. So pH is 14 minus 1.778. Da, 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 da. So my final answer for pH is, James?
12.22.
12.22, and I round off to two significant figures. So this is going to be 12. Does it have units?
No.
No. So it's just 12 with two sig figs. Okay, and that's your working out. Bonus points, guys. What temperature am I doing this mixing at? Hadia.
25 degrees.
25. Hadia, that's what you're going to say, right?
Yeah.
Okay, if it wasn't, you just nod anyway, okay? So pH plus pOH is equal to 14 is 25 degrees Celsius. It's defined at 25 degrees Celsius. Remember, that's one of the things we talked about, yeah? With these equations, when you know what temperature it's defined at, keep that in mind, because so Saban, you were talking about like practical exam skills. Some of the things they ask you is what kind of assumptions you're making about the experiment you're doing. If it's pH plus pOH is equal to 14, that equation is only defined at 25 degrees Celsius. So if you do an experiment in class involving that equation, one of the assumptions you're making is that your classroom is at 25 degrees Celsius. All right. Good. Okay. Have a go for me, guys. Actually, one more thing I will point out. Strong calculations. HCl and NaOH are both strong. The questions that you'll see in homework are also strong acids and strong bases. If it's weak, the calculations will probably take this much to do. Yeah, keep that in mind. Label it on your paper for me, because a weak calculation, they look different, okay? So you can memorize a step-by-step for this, but you want to memorize it for the weak ones look different. So you want to be able to adjust to that. Have a go for me, guys, in real class time at question 74. I'll stay muted here. If you have any questions, unmute yourself or type it in the chat. Yeah, I'm going to give you the chance to have a go at this on your own. Okay, with question 74, the process is the same. The only thing I'll ask you to watch out for is that this time it's BaOH2. So then when you go to calculate OH minus, what do you have to do to the moles of BaOH2 to get to the moles of OH minus? Because it's not a 1-to-1 ratio anymore.
Times by 2.
Times by 2. So guys, BaOH2, there's 2 OH minus in the entire molecule. So when you go to calculate moles of OH minus, it's 2 times the moles of BaOH2. And then the rest of your calculation is the same. Have a go at 74 for me. I'll pop 10 minutes for this. 8:25, we'll come back together. Yeah, we'll see how you guys go. If you finish, some of you guys are faster than others. If after 74, have a go at 72. 74 first, 72 second. Stay on call, unmute yourself if you need to, or type it in the chat. Yeah. what I meant by strong calculations was that the acids and the bases that you're dealing with are strong, as in like they dissociate completely. So you don't have to worry about the reversible arrow. When you get to weak acids and weak bases, you start having to consider equilibrium constants and ice tables. And yes, we will learn about that when we get to it. Remember, if you're done with question 74, move straight away to question 72. If you're done with that as well, just let me know and we'll move you on again. Let me know if you have any questions, guys. If you're done and want to check your answers, 72 should be B, 74 should be C. check your answers along with me as you're going. And just stop me whenever you have a question about one of the steps, yeah? After the 0.013 bit, now that I've got the moles in excess, I follow my steps and I go to do concentration. So what I've done here is C is equal to N on B. 0.0. Oh, yeah, so this is the total volume after I've mixed the two together. So the acid was 20 mils and the base was 5 mils. So I've just added the two together to get the final volume for the mixture. Yeah? Okay. I have no space. Okay. finish off your responses. Have a look at what's on the board. Let me know if you have any questions. This works best if you do have questions, by the way. Normally in class, I'll just budge in even if you don't have a question, okay? But when we're online, I'm going to rely on you guys to take a bit more initiative, okay? Take a screenshot of the screen if you're still getting it down. Don't copy it though. Save it on your desktop, do the question on your own, then come back to check it. Okay? All right. Yeah, Noyo, what is up?
When we multiply the moles of barium hydroxide, no, is it barium hydroxide? By 2, why does that work? Like, why do we do that?
Because you can figure out the moles of the acid and the base completely, like moles of HCl and moles of BaOH2, but then your limiting reagent calculations get a bit more annoying because you have to consider these ratios at the front. But I go ahead and calculate the moles of H plus and OH minus straight away because that reaction is always a 1-to-1 ratio. So it's easy to calculate. It's easy to just compare the numbers. So for OH minus, the bracket around OH in the formula has a 2 on it. It means that if I have 1 mole of BaOH2, there is 2 moles of OH minus inside of that. That's like how if you have 1 molecule, then there's 2 OHs in it. So if I get the moles of BaOH2, I have to times that by 2 to get the moles of OH minus. So that's just ratios looking at the formula.
Okay, yeah.
Oh, good. All right. Waiting for anyone? Okay, guys, can you jot down for homework for me? Questions 69 down to questions 82. Questions 69 down to questions 82.